All right, guys, so today we're learning about the half angle formula. Who's excited? And our target, how do you use the half angle formula? Well, first of all, I'm going to give you all of the half angle formulas, okay? All right, our first one. Sine of theta divided by 2, right? Double angle, we found the sine of 2 theta, right? Half angle, we're going to take half of, we're finding the sine of half of theta. And that formula is plus or minus the square root of, this is a fraction, 1 minus the cosine of theta, quantity divided by 2. Then we have the cosine of theta divided by 2. And that equals positive or negative, plus or minus, however you want to say it, the square root of 1 plus cosine at theta quantity divided by 2. And then tangent of theta actually has 3. Or tangent at theta divided by 2 actually has 3. One of them is positive or negative, the square root of 1 minus cosine at theta, quantity divided by 1 plus cosine at theta. Another one, tangent of theta divided by 2 equals, there's no radical here, there's no plus or minus, 1 minus cosine at theta, quantity divided by sine at theta. Or tangent of theta divided by 2 equals sine at theta divided by 1 plus cosine at theta. And notice there, for 3 of them, the radical, you can take the positive or negative root, right? We know whenever we have a root that's even, square root, 4th root, 6th root, 8th root, the result can always be positive or negative. But if I'm finding the sine of theta or the cosine of theta or the tangent of theta, the sign obviously depends on what quadrant it's in, right? So your answer is not going to be positive, negative, some number. You got to pick one, which I know you'll know that. But will you remember it when you're reading back over your notes in a couple of years from now? Because I know you're going to be. All right? It could happen. So let's just make a quick note of it. The positive or negative symbol in each formula does not mean that there are 2 possible values for each function. Instead, the positive and negative indicates that you must determine the sign, S-I-G-N, of the trig function be it positive or negative based on the quadrant in which the half angle theta divided by 2 lies. We good? Okay. Of course it is. Keep doing that over and over and over. All right, if we know the exact value for the cosine of an angle, if we know the exact value for the cosine of an angle, we can use the half angle formulas to find the exact values of sine, cosine, and tangent. For example, we know that the cosine of 225 degrees equals negative square root of 2 over 2. In the next example, we are asked to find the exact value. So exact means you can't use your calculator because they don't want your decimal answers. To find the exact value of the cosine of 112.5 degrees. Do we know how to find the cosine of 112.5 degrees without using our calculator? No. Guess what? That value is half of 225 degrees. So sometimes they'll ask us to find sine, cosine, or tangent of an angle we don't know. But if we double that, that value that you get after you double it, it might be the value of an angle we do know, right? And if so, we can use those half angle formulas to help us. If you double it and it's not an angle that we know from the unit circle, then you can't use the half angle formula, okay? I know it sounds kind of weird so far, but just give me a chance. Example 1. Find the exact value. So no decimals here. Of cosine at 112.5 degrees. Okay, so 112.5 degrees is not on a unit circle. But if we double it, we get 225 degrees, which is on a unit circle. So we can use, yes, I do. Yes, can I wait till a few minutes? Or does she need to come now? Okay, you're welcome. So again, 112.5 degrees is not on the unit circle. And I can use my calculator to find the cosine of 112.5 degrees, but it said exact values. So my calculator is going to give me a decimal, right? I'm going to have to do some math here. All right, so they're wanting us to find the cosine. And did the half angle formula for cosine, it only had one formula, right? You know how tangent had 3 formulas? Well, cosine only had one formula. So, no problem, Jamar. I marked you absent, but I'll fix it. Okay, so that formula was cosine of theta divided by 2 equals positive or negative square root of 1 plus the cosine of theta quantity divided by 2. No, it's the second page of notes. Okay, so this part's kind of weird. So for cosine, I'm not going to put 112.5 in for theta because 112.5 divided by 2 is not the cosine of 112.5, right? So what do you think I'm going to put for theta? 225, because that divided by 2 is 112.5 degrees is what we're trying to find. 112.5 divided by 2 is not what we're trying to find. So positive or negative the square root of 1 plus the cosine of 225 degrees. That's what we plugged in for theta, not 112.5, divided by 2. Okay, well, what quadrant is 225 degrees in? Quadrant 3. How far past 180 do we need to go to get to 225? 45 degrees, right? So that means my reference angle is 45 degrees of the 225 degree angle. What is the cosine of that angle? And it is negative. And also the sine is also negative square root of 2 over 2, but I don't really need it for this problem. I'm just being thorough. So go back to my problem. Positive or negative square root of my numerator will be 1 plus negative square root of 2 over 2 all over 2. Now, me personally, I would probably get rid of the complex fraction by multiplying everything by what? 2. So that equals positive or negative square root of 2 times 1 is 2. And I know that plus a positive times a negative, I'm going to be subtracting that, right? Square root of 2 divided by 2 times 2 is the square root of 2 all over 4. Okay, now this is soups weird, okay? Remember, your numerator and denominator are both under the radical. So if I could take the square root of any part of that separately, I can do that. I don't have to take the square root of the whole thing. So I'm not going to rewrite it if y'all understand what I'm saying. What the denominator is also under the square root, right? What is the square root of 4? 2. But my numerator, I can't take the square root of 2 or the square root of the square root of 2 without being a decimal. So my numerator is the square root of 2 minus the square root of 2. But make sure that 2 in the denominator is not under the radical because we already took the square root of the denominator, which was 4. Now, is that my answer? Can I have a positive and negative cosine? No, I cannot. What would the cosine of 225 degrees be? Negative. So it's going to be negative square root of 2 minus the square root of 2 all over 2. Would your calculator give you that crazy answer? No. I know it looks weird. We've never had a radical under a radical before. But that's the answer. Anybody have a question? All right, example 2. So let me just bring this down. The cosine of 225 divided by 2. This is the answer. Yes. You don't think someone's up there waiting for you, do they? Oh, okay. I have 2 more examples. So, yeah, I'll just wait. All right, example 2. It is February 25th. Find the exact value. Of 105 degrees, or cosine of 105 degrees. Is 105 degrees on the unit circle? No. Okay. Well, what if we double it? We double it, multiply it by 2 is 210 degrees on the unit circle. So let's use, since we doubled it, we can use the half angle formula to find the cosine of 105 degrees. So that formula, cosine of theta divided by 2 equals plus or minus the square root of 1 plus the cosine of theta, quantity divided by 2. So let me go ahead and figure this out. Where is the 210 angle going to be located? What quadrant? Quadrant 3. How far past 180 do I need to go? 30 degrees, right? To get to 210. So that means that my reference angle is 30 degrees. The angle across from 30 degrees is 1/2. The angle across from 60 is square root of 3 over 2. What is the cosine of that angle going to be? What is it? Negative square root of 3 over 2. And the sign, not that it's asked, but it's negative 1/2. Just to be thorough. So we're going to find the cosine. What am I putting in for theta? 210, because 210 divided by 2 is 105. Equals positive or negative. At this point, we could say which one. The 105 degree angle, because we're finding actually the cosine of the 105 degree angle, right? What quadrant would that be in? 2. So what's the sign going to be for an angle in the second quadrant? Or the cosine going to be for an angle in the second quadrant? Also negative. So we know we're going to end up picking negative, right? So I don't need to say both of them the whole time, or I can, but I need to pick one and end. So instead of 1 plus the cosine of theta, we're going to have 1 plus negative square root of 3 over 2 all over 2. I don't know why I picked 2 cosines instead of doing a sine and a cosine, but sine, same thing. It's just formula is minus sign here instead of a plus, but you do the same thing. So let's get rid of that complex fraction by multiplying everything by 2. So we get negative square root of 1 times 2 is 2. I know positive times a negative, I'm going to get a negative there. 2's are going to cancel out, and I'm going to have the square root of 3 all over 4. Now, if I wanted to write the square root over every little part, no, you can't do that. Never mind. So equals negative. Can I take the square root of 2 minus the square root of 3? No, that's not a perfect square. How about the square root of 4? Is 2, right? So that radical, I'm not going to have a radical in the denominator. The numerator is going to be the square root of 2 minus the square root of 3. Julio? I've got one more for you, and then tomorrow we'll do the assignment. Not too hard, right? Example 3. We do need to do a tangent one because we have 3 different half angle formulas for tangent. The good news is you can pick whichever one you want to. They're all the same. They're just in different forms. So you don't have to determine like, oh gosh, which one should I use? You can use whichever one you want. So let's find the exact value of tangent at 75 degrees. Do we know, is 75 degrees on our unit circle? No. Could we use our calculator to find the tangent of 75? Yeah, but in decimal form, but we want exact values. So on tangent, oh, so wait, what's 75 times 2? 150 degrees. Is every angle they ask you for the tangent, cosine, or sine of going to be half of an angle on the unit circle? No, it's not. But if it is, then you can use one of these formulas to find whatever else it's asking you for. Okay. Oh, I wanted to make sure we wrote in our notes, use either of the tangent of the half angle formulas for tangent. Now the one under the radical, we only need to figure out what the cosine of tangent is, right? But it's all under the radical, which is a little bit confusing. The other two aren't under the radical, but we needed to know sine and cosine, and those both look like the same bit of difficultness, but they're not under the radical. So you pick what you want. I'm probably going to choose one that's not under the radical. You know what I'm saying? But I'll have to find the sine and cosine first, but okay, we can do that. No biggie. All right, so well, let's see. We know to find tangent of 150 degrees, we first need to find the sine and cosine, right? And we don't even have to find the tangent of 150 degrees. We just have to find the sine and cosine, which we're going to see anyway. As soon as we pull the unit circle, we'll know both of those anyway. So easy enough. What quadrant is 150 degrees in? 2. How far past the 90-degree angle should I go? 60 degrees past to form 150 degrees. So what's the measure of my reference angle? 30 degrees. All right, so what is the cosine? Negative square root of 3 over 2. And what is the sine? Positive 1/2. So I'm just going to use the formula tangent of theta divided by 2 equals 1 minus the cosine at theta, quantity divided by the sine at theta. And there's no radical here, so I don't have to choose plus or minus, right? I just plug in the formula, whatever it says. So I'm finding the tangent of, what do I plug in for theta? 75 or 150? 150, because 150 divided by 2 is 75. 75 divided by 2 is 9. Equals 1 minus, the cosine was negative square root of 3 over 2. So I have a double negative there. Don't say, I already have a negative. I don't need to put another negative. I'm subtracting a negative. All over, sine of theta is 1/2. So what can we do to get rid of these fractions within fractions? Complex fractions, we call them. Multiply by 2. Even that 1, don't forget that poor little 1. Every term has to be multiplied by 2. Every term within the fraction. So we get 2 times 1 is 2. Now, what's negative times a negative? Positive. And square root of 3 over 2 times 2 is just square root of 3 all over 1, which I don't need to write that. So just 2 plus the square root of 3. or the square root of 3 plus 2 would be fine as well. So the tangent of 150 divided by 2, or you could say the tangent of 75 degrees, same thing, is 2 plus the square root of 3. Coolio? Anybody have a question about that? All right, so we will do an assignment on this next class. No assignment today. Please, if you're at home, if you have not turned something in, please work on getting that turned in now. If you haven't submitted something, if you are here in class and you have not submitted something such as handing it to me, please work on that now because we still have like 10 minutes till lunch. All right, and I'll post this video as soon as it's ready. And everybody at home, you can go ahead and log off so I can get this video working. Hold on, I got a question. Let me answer the question. Yes, tomorrow I will put the first page up so you can see it. Oh yeah, let me write you a pass. Let me stop recording this.